All right, so this is lesson 33. Get a full screen for myself, if I can figure out where that is. Maybe that's it. Yep, there we go, so I can see everything. All right, so I'm assuming in lesson 33 here that you've done the other lesson sets, so I'm not going to talk about or write down too many instructions. I mean, it's very repetitive here, and it's so repetitive so that we can hopefully get to the point where many of these problems are just automatic, right? And you want them to be automatic because you'll be using these calculations down the road when you get into higher level classes. And what you can do with these functions, many of these functions are going to become rate functions. And as such, as rate functions, then we manipulate them to find out position and acceleration, and we start getting into a little physics and using the math to study relationships out there in the real world. Well, to get there, we got to have the foundation necessary to support conceptual understanding at a higher level. And we don't want these problems to get in the way. How do I graph the LN function? Well, coming out of these courses, you're supposed to know so that you can then use the LN function to study other things. All right, so we're doing a lot of reps so that we become timetable-like. 3 times 5 is 15. I don't have to think about it, nor should you. And when we do most of these problems, we don't want to have to think about things. All right, we want to be able to consider how we're going to use the mathematics to solve some problems and study the world. All right, so there's my rant. Ln of e to the, I'm going to, so you're going to pause the video, obviously, and I'm just going to continue right on through. And if I make a careless error and get hung up, I might even abandon the problem because sometimes I can't find out that I made a little sign error here and a little blockage, writer's block, whatever you want to call it. And then the video is just going to take forever. So sometimes that happens and I'm not going to worry about it. We all make mistakes. You're going to make them. I'm going to make them. But the more we practice, the fewer we make. And if we can learn from the mistakes, then hopefully won't make them again. All right. So e to the 8 to the 3 is e to the 11. E to the 5, e to the 11, e to the 6. What's the exponential activity on top of e? -12. Right? Sign changes or no sign changes? Well, 4 is a root, x-intercept, and it's to the second power, so therefore add 4. I'm not going to get a sign change. It doesn't matter if I put a 3 or a 5 in here. Squaring it makes it positive. No sign change. Going to get a sign change at 1. That's a linear. I wrote the 1 in there. This is odd as well, so sign change at -2. All right, and I'm going to graph this. No, I'm not going to graph this. I'm just going to do true or false because it's a division problem. So I'm just going to write true or false. If I put 1,000,000 in here, that's positive, that's positive, that's positive. So that's true. So that's true. That's false. That's true. Now, for those of you who are just learning this, throw some numbers in there. You got to work with numbers. So I'll just throw a 2 in here to show that it's still true. Always positive. 2 minus 1 is positive. 2 plus 2 is 4. 4 cubed is positive. A positive divided by a positive. Positive times positive divided by a positive. That's true. Right? And you can throw other numbers in to prove that. So -infinity to -2. Union 1 to 4. Union 4 to infinity. Right? Because I did not put an equal sign here. So I'm not putting a bracket there at all. All right, so that's done. Next problem. The way to rewrite that is as follows. 1/16 to the -4. What does that become? I'm going to take the reciprocal of 1/16, which is, oh, it was -1/4. Excuse me. I knew I did something. There. Now I'm back to where I want to be. So I'm going to take the reciprocal, which gets me 16 to the 1/4, which means the 4th root of 16, which is 2. Okay, that one's done. Let's do a little erasing as we go, which means I'm committing myself to making a stupid mistake, and you'll get to see it somewhere in the next 60 problems. We're doing problems 40 to 107 in this video. Should have said that at the start. So we have a 30, 60, 90 triangle. Hopefully we're getting familiar with that, with a hypotenuse of A. So that's half of A. And that's √3 times A over 2. All right, so what connects these? √3 is a factor. What connects those? 2 is a factor. You want to get bigger to smaller, divide. You want to get bigger to smaller, divide. All right. We're looking at writing this as a product. So we're working with the cube roots, 4m minus 3y. Squaring, 16m squared. Changing the sign. 3 times 4 is 12, my. And squaring the last term. Okay. You've been keeping an eye on these problems. Those are always positive. Doesn't matter if it's negative or positive. Both positive terms. All right. Not quite sure why I wrote this problem the way I did, but I wrote it that way. So taking a look at it, and I already did this one out because I wanted to save some time for you. There's no, the minimum we have in this problem is x to the 5th, right? We don't have a single x to the 5th term coming out of this. So I just did multiply, 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 boom, 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 and then multiply, 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 boom, boom, boom. And there are no like terms, so there's no reason to put it into columns. Still wondering why I wrote it that way. So I'm going to flip 1 over 25, gives me 125 to the 1/3. That's the cube root of 125, which is 5. Cube root of 16 could have been written as the cube root of 8 times 2. X to the 30th could have been written as x to the 10th cubed. Hope you can see why I'm doing that, inverse operations. Y to the 20th is y to the 18, y squared, and z to the 8 is z to the 6th times z squared. Now, anything that's got a multiple of 3, I'm going to cancel and bring out, so 8, the cube root of 8 is 2. The cube root of, so that one's taken care of. This one can be taken care of, that's x to the 10. That can be taken care of, y to the 6th. That can be taken care of, z squared. And I still have cube root of some stuff that's left. A 2 is still inside the radical sign. So are y squared and z squared. Most of you are getting those right now anyway. All right. So square root of 5 times the square root of 10 is square root of 5 times the square root of 5. You want to look at this kind of in factored form. 2 √5, √3. Okay, so what's the square root of 5 times the square root of 5? By definition, it's 5. So there's 5 √2 minus another √5 times √5 is 5 times 2 is minus 10 √3. And we're done with that one. No like terms. Those radicals aren't the same. It's kind of like adding 1/2 and a 4th, 1/2 and a 5th, right? Not common denominator. Well, if we don't have common radicals, you can't add them up. Can't count them. All right, number 51. That's why I wrote this. What is a radian? Intro to the unit circle. My understanding at this stage is we've talked about it. You've looked at it. It's been in the video. I've asked you to look at it for weeks. If you haven't, it's on you. All right, so this one here, I'm going to solve that. Saved a little time. Take 2 away. It's 2.5. That takes care of that. Divide by 40. Well, I'm going to divide 2.5 by 40. I'm going to divide everything by 5. So that's 0.5 divided by 8. And that's the same thing as 1/2 times 1/8. Dividing by 8. It's the same thing as multiplying by 1/8, which is a long way for us to get 1/16. Now, I'm going to take the base and turn it into a log. Log 1/2 of 1 over 16 is 4. Then I am going to add 3 to get 7. Hopefully that's correct. You can check it out. Make sure. Okay, can you do that one in your head? Let me erase this, get some space. All right, let me try it. So 7 pi, another pi over 3. I think I'm at minus 1/2. Let's check it. Remember, you're pausing the video. There's a circle. 21 pi over 3 is what I'm seeing as a reference point. And I got to go one more. One more. So that puts me there. Okay, there's chunks of 3. So I have a 60-degree chunk. When I draw a good drawing, then that's minus 1/2. And the hypotenuse is still positive 1. So adjacent divided by hypotenuse. That was correct. 25/6 as an approximation, and then also we'll do it using the rules of logs, which I will do in my head right now. 1.6, 3.2 minus 1.8. 3.2 minus 1.8, I believe, is 1.4. I think our answer is going to be this, but let's go find out. And then let's develop our rules of logarithms from that. So 25/6 would be written that way. 5 is e to the 1.6, roughly. I didn't write that well. E to the 1.6 squared. Okay, so we're going to square that. And 2 is e to the 0.7, e to the 1.1. And I think I said 3.2 minus 1.8, and that's 1.4. So that was correct. Now let's look at this from the context of the rules of logarithms. All right, so I'm multiplying 2 times 1.6, which is 2 ln of 5, which means that that is the same thing as the ln of 25. All right, but here's it is simply written as possible. 2 times the ln of 5 minus what? Well, I've got this is e to the 0.7 plus 1.1. Okay, so how do I want to write that? Minus e to the 0.7, which is the ln of 2 minus the ln of 3. That's where we're headed to be able to change that to this and vice versa. All right, so those are the rules of logarithms, and we could have seen that, hopefully eventually see that, not the 1.4, but this statement turned into that and understand why. Not just mechanically getting it right, but actually seeing the exponential activity is the goal. Okay, so here we're going to take $100, we're going to double it 5% interest. So this is one of those A equals PE to the RT. Again, we're going to talk about compound interest after we get mechanically sound. Once we're mechanically sound, then we can start getting into where the letter E comes from and other discussions around compound interest. All right, so if I'm doubling, our answer is going to be ln of 2 over 0.05. Let's see why. Let's take this and write something where we take $100 and double it. 0.05t, that's what we're solving for an equation. It's going to become 0.7 divided by 0.05, which is the same thing as 70 divided by 5, which is 14. That's where we're headed. So we divide by 100, there's our 2, e to the 0.05t, ln of 2, the inverse operation, 0.05t, and then we have the ln of 2 divided by 0.05. If I wanted to triple, I think that 2 becomes a 3. All right. Oops, I still have more here. All right, so here is the ability to do what here? The ability to see the rules of logarithms. So that 1/3 can go here. Right? And that 8 can become 2 to the 3. Right? And I'm adding 3 ln of 2 means I could have had ln of 2 cubed, which is the ln of 8. Well, these cancel, right? So that's the ln of 2 plus the ln of 8, which is the ln of 16. Okay, that is the ln of 2 to the 4 if we want to get an approximation, right? And that's 0.7 times 4, right? So that's going to be 2.8. And it's just a little approximation, get a feel for that calculation. All right, if 5 is a root, now this is one I made a mistake I was talking earlier at the beginning of the video. When you make a mistake, you hopefully learn from it. And I inadvertently wrote x plus 5 when I was trying to find, if it's a root, if 5 is a root, then x minus 5 is a factor. Right, and that's where I went wrong one time a couple of videos ago, and Christ, it threw me for a loop. Not going to let that happen again. So x minus 5 times what is going to get us, I guess I should just write it here. X cubed minus 6x squared minus 15x plus 100. Now, if I created this problem properly, I'll get no remainder. So that's x squared minus 5x squared. I need another one to make minus 6x squared. Now I've got positive 5x. I want minus 15x, so I want minus 3. And I don't like this because I think that's not true. Right? Minus 3 times minus 5. I wonder if this was a 10. Minus 15. 5. Let's see if it's a root. Let's put 5 into this. All right, 5. 125 minus 6 times 25 is 300, I believe. 6 times, no, it's not 300. It's 150. 6 quarters, yeah, 150, buck 50. 5 minus 75 plus 100. All right, so that's minus 25 minus 75 plus, okay, so it is a root. So therefore I did something wrong here. All right, so I just wanted to check that out. I said this might happen, it did. So x minus 5, x squared is correct. Minus 5x squared to minus 6, that's correct. That's positive 5x. How do I get from 5x to minus 15x? There's my mistake. How do I get from 5x to minus 15x? I got to go down 20. There we go. Okay, so what do I have now? Now I've got x minus 5 times x minus 5. So that's a double root times x plus 4. Okay, so the only other root besides 5 is 4. And so if it's a double root, that should be there. 0 gets us 100. So way up here, I'm going down at 15 to 1. I'm going down pretty darn quickly. So I guess it probably looks like an negative 4. Right? So it probably looks something like this if we threw it in a calculator. That's my guess. All right. Previous videos, we said this is the same thing as this. Okay, so 11 pi over 3, the sine of 11 pi over 3 should be minus root 3 over 2 squared is root 3 over 4 times 5 is 5 root 3. Well, I lost track of my train of thought. So 11 pi over 3 is close to 12 pi over 3. Okay, so we're one less. So hopefully you're doing that quickly now. So 11 pi over 3 going this way, right? I'll go on this way, excuse me. So we're right here. That's 11 pi over 3. So that's negative root 3 over 2. I'm going to square that. If I square that, I get positive 3/4. Okay, so I did lose my train of thought before. Times 5. The answer should be 15 over 4. All right. Now, I'm not organizing these things. I'm just talking as we go along, and that's our practice. Hopefully you follow. Hopefully you're doing them right yourself. This is about our 4th or 5th day doing problems like this, so it should be meaning a little bit more to you each and every time. Domain, just get the numbers that matter. 5 matters and negative 9. 5 and negative 9. All right, so now the question is, what can I use? Can I use negative 9? Yeah, square root of 0, it exists, and 5 minus a minus 9, so yes, I can use negative 9. Can I use numbers bigger than 5? I don't think so, because that becomes the square root of a negative number, and that's not on Rene Descartes. It's not on a rolling cart. No, can't use these numbers. Can I use the number 5? Absolutely not. Can't divide by 0. Can I use numbers less than negative 9? I think we said yes to that. Maybe we didn't, but I can see can we? No. No, if I put a number less than negative 9, negative 10, no, I'm sorry. That was a misstatement by me a second ago. Can't use them. Can I use these? Yes. So what do we have? We have x values that can be greater than or equal to negative 9, but they must be less than 5. That's the domain of that graph. Be interesting to play with that and see what it looks like. If you were gonna, well, that's not the best example to use at the stage we're at, so I'm not gonna do that right now. Average rate of change for ln of x from 2 to 3. Well, that's simply the ln of 3 minus the ln of 2 over 3 minus 2. y2 minus y1, x2 minus x1. What is that? Is it a positive slope or a negative? Going up at about 4 to 1, 0.4 to 1. One ln of 3 is approximately 1.1, ln of 2 is 0.7. All right, so we're going up at a very slow rate. And the ln of x, what's it look like? Should know that now. That should be automatic. The ln of x equals 0. 1 gets us 0. 2 gets us 0.7. 3 gets us 1.1. Right? Does it look like it's going up here at a very less than 1 but positive ratio? Yes, it does. So that's good. Tangent of x plus root 3 equals 0. We're only doing this for the unit circle. So where do we get the tangent of x? Equaling negative root 3 to 1. Moving that over. Where do we get that? Well, we've talked about the 30, 60, 90 triangle. Right? And that's a root 3 over 2, 1/2, 1. And if I double it, that's a 2, that's a 1, and that's a root 3. So when would I get a root 3 to 1 ratio? The 60 degree, right? Just tip it on its side. All right, and it's got to be negative. So where is the tangent function negative? Well, not in the first quadrant, but it sure looks like 60 degrees here will get us a root 3 to 1 ratio, a 2, a root 3, and a 1, and this 1 is negative. So it works there, and it works there. All right, so what's the angle? 120 degrees, which is 2 pi over 3. And over here, 6 pi over 3 is once around, and I think we're 1 less than that. 5 pi over 3. All right, now remember, new material takes time to process. It takes repetition. You're getting one look. One look. All right, you want to get another look? Not only do it in class today, look at the video. Repeat what you did. It's all about recall. And how do you get recall? You recall. That takes a little effort. All right, so multiples of 3, 2 plus 1 is 3. 3 divided by 3, it's a multiple. Yep, so that can be divided by 3. And so can 30. So I'm going to do cube roots. So 4 is the cube root of 64. And x to the 7th is the cube root of 21. Plus 3 by 10. Those are our cube roots. What do? We square the first. 16x to the 14. Square the last one, 9y to the 20. Those are both positive. We change the positive to a negative to get the cancellation of the terms. 4 times 3 is 12. X7, Y10. X7, Y10. All right. Now, it's easy to throw numbers in and get, just look what works as I'm giving you integer values. But I'm not going to give any partial credit anymore, and I want to know if there's one answer or two answers, and that's going to make you do the problem, I think. So 4x plus 1, negative 1/4 is the most important number here, because that's where this graph starts from. And it's going up pretty quickly for square roots, 4 times faster than the parent function. X plus 1. X plus 1, well, 1/4, so 1 is somewhere up here, might have an intersection, and we might have another intersection somewhere else because we're going up at 1 to 1. It's odd. We've got to figure out what's going on here, and I'm not sure from my graph. I don't like the fact that I didn't nail it, so I'll square that, 4x plus 1. I'll square that, x squared plus 2x plus 1, and I'll do the algebra. Set it to 0. The 1's cancel. Don't have to do that. So I'm looking at x squared minus 2x, which is equal to x times x minus 2. So there should be answers at 0 and 2. Let's check it. 8 and 1, 9. Square root of 9, 3. 2 plus 1, 3. 2 works. 0. Well, we could have seen that from the start, right? 0 works. Okay, so it did intersect at 0, 1. E to the minus x. I hope you have that in your head. Y equals 0. what do we have? We have negative 1.1 gets us close to 3, negative 0.7 gets us close to 2, 0, of course, gets us 1, so on and so forth. So if I keep getting bigger and bigger x's, sure looks like my y values are heading towards 0 over here, 0 over here, right? Closer and closer to 0. As x's get bigger and bigger, remember e to the minus x is the same thing as 1 over e to the x. And as this gets bigger and bigger and bigger, the fraction gets smaller and smaller and smaller. That's the conversation you need to have. So that's done. All right, so what did we say we could do with those parentheses if we're adding? Multiply. So I've got x times x plus 2, which is x squared plus 2x. I'm going to bring, well, I'll write log base 2 at this stage, right? We should now know at this stage that to change the form, that becomes x squared plus 2x equals 2 to the 3. We should be there at this stage. This is a retread problem anyway. All right, so what do we have? We got x plus 4. Can't use that. Can't use negative 4. Can't have negatives in the parentheses. X plus 2, x minus 2. So you check x equals 2 real quick. Put a 2 in. What do you put on top of 2 to get a 2? A 1. Put a 2 in, we get 4. What do you put on top of 2 to get a 4? A 2, and 1 plus 2 equals, happens to equal 3. All right. Piecewise function. I'm seeing V-shaped down. I'm seeing negative 2. Makes a 0. That's a minimum. And that's going to become a maximum because I'm going to multiply a minimum times a negative. Makes it a maximum. So I see that. And I know that on this side, I'm going up at 10 to 1. And on this side, I'm going down at 10 to 1. And we've thrown numbers in there. Like what? What numbers have we thrown in? Like 0. Let's do it one more time. So that's absolute value of 4 is 4. Minus 20 plus 1, minus 19. How do you get from 1 to minus 19? You go down 20. How do you get from negative 2 to 0? You go up 2. Oh yeah, I am going down at 10 to 1. So what's the piecewise? I'm going to build this off of Alfred Hitchcock. No, off of the vertex. And the vertex is minus 2, 1. So x plus 2 plus 1. And that's going to happen when x's are less than negative 2. I'm going to be going up at 10 to 1. Down at 10 to 1. When x's are greater than or equal to negative 2. All right, now we're going to set this thing to equal negative 29. All right, let's get one answer. And then let's use negative 2. Negative 2 is our center line, our axis of symmetry. So I'm going to subtract 1, minus 30. I'm going to divide by negative 5, which is 6. I'm going to subtract 4, which is 2. Then I'm going to divide by 2, which is 1. All right, so one of my answers is 1, which is over here. And then the other answer has to be 3 units to get to 1. So it should be negative 5. We'll just check it. Minus 5 times 2, negative 10 plus 4, negative 6. The absolute value of negative 6 gives me a magnitude of 6. Minus 30 plus 1, minus 29. Those are my two answers to this equation equaling negative 29. Now, when am I greater than negative 29? Well, it's a V-shaped down, right? And this is where I'm 29. So these y values they are between negative 5 and 1. But we could also come over here, put a 1, put a negative 5, and just try numbers. Try a number like, and remember, these are linear, so I'm going to get sign changes. So let's put 1,000,000 in here. If I put 1,000,000 in here, I got minus 5 million plus 1. I don't think the 1 matters much. Minus 5 million. Is that greater than negative 29? I don't think so. All right, so this would be false. Therefore, we get the sign changes. And we said that these numbers don't work. Those y values are underneath a height of minus 29. These are not. And so these x's, all those numbers between what? between -5 and 1 work. So x is less than 1, greater than -5 is probably the best way to communicate that. All right, what? Right as a product. I'm seeing a binomial square. Man, the last video, I made a sign error and I corrected it in the video, but this time that repetition helped me. From one lesson set ago. Look at that. I've been at this how many years, but in my mind's eye, I'm going, don't make that mistake again. Name that tune. You haven't done a lot of work with ellipses, but I hope that we've done enough that you might say x minus 5 squared and you might say y minus 7. And you've seen it enough that maybe you set it to 1. But we have different axes. How do I get from 7 to 10? That's vertical, 3 units of change. So I'm going to write a 9 here. How do I get from 5 to 11? That's 6 units. It's 36. Now, we practiced getting some coordinates. If you put 5 in here, then what works? Well, I got to make that a 3. So 10 works, or -3, and that would mean 4. So this would be 5 comma 4. Right? You can do the same thing. Let y equal 7, and you'll find that number and another one over here. I'll leave that to you. All right. Name that tune. Trying to give you a little challenge here. Name that tune. Let's get this out of the way so you can concentrate on that one problem. All right. And I wrote c minus 3ah squared equals 0 because I'm hoping that maybe by writing this, you might say, well, what does that represent? That's the slope at that location. Okay, so that I'm giving you that. I'm saying that's flat right there. I hope you can see that it's flat. We'll be looking at why it's flat in another couple of weeks when we really look at the geometry of change for cubics. All right, we'll hit this with some real conceptualization as to why that's a point of inflection. But right now, we're just trying to get mechanics. So if that's a point of inflection, then this is not necessary to write, but I'm writing it anyway because this is the graphing form. Right, plus 2, that's the graphing form. The only thing I'm missing is this multiplier. So what's that multiplier? In this case, change by 2, but I'm cubing, so I don't want 8 units of change because I'm going from 2 to 9. I just want 7. So this was the graph of y equals 7/8 x cubed plus 2. Does that look familiar? The thought process? I hope so. I hope so. All right. So that's that. I wish all cubics were as easy as that, but they're not. So what's the inverse of this? Remember, you're looking at the inverse operations for solving, setting something equal to a number. What are the steps you take? Well, first step I have to take is log base 2 of that number. What am I going to call that number? I'm going to call it x. That takes care of that operation. Subtraction of 3 becomes addition of 3. And if you write log base 2 of x plus 3, I'm sorry, I can't give you full credit for that. Right? Because is there a parentheses here in your mind's eye? I don't know. Right? So this is what you wanted. How do you check your inverses? You use numbers. How do you get better at math? Yeah, plug numbers in and see what happens. If you're not crunching these numbers, you're not getting the best experience that you can get. Probably other things I should say about that. But what's easy to work with? A 2. All right. So what's the exponent you put on top of the 2 to get a 2? 1 plus 3 is 4. Therefore, if a 2 gets me a 4 here, a 4 better get me a 2 here. 4 minus 3, 1, 2 to the 1, 2. I'm moving on. Okay. Hope I haven't made any careless errors yet. I'll find out. I usually look at a video and I go, oh, how did I do that wrong? Too close to things. All right, so 1/9, I can do this here, is 3 to the -2. 27 is 3 to the 3. The bases are the same, so I can get rid of that concept here, that mechanic. What do? You multiply, so that's 2x. What do? You multiply, that's 9x minus 6. So I've got 7x equals 6. My answer is 6/7 for that problem. I hope you're practicing here at home. Changing to E notation. putting it in that A equals TE to the RT form. I know what 3 is, it's e to the 1.1. Approximate E notation. And that 1.1 can be put right there. Power to power is multiplication. Divided by 100 is moving the decimal places 2 units to the left. So that function, if I saw it, I would look at that and go, geez, that looks like it's tripling something every 100 years. Of course, I did that, right? I got to get rid of that. Sorry. Forgot to do that. So 0.011t is what we wanted to write. All right, so the next one we're going to graph because it's important for a calculus class that you know how to graph these. So you'll learn it at the earlier level, which happens to be right now. -2, linear. Sign change. X minus 3 cubed. 3, sign change. Odd number. Even, no sign change at 0. What's the graph look like? Put 1,000,000 in, 1,000,000 in, 1,000,000 in. Oh, that's positive, that's positive, that's positive. Is that greater than or equal to 0? I would say true. So, boom, boom. Oops, this is a cubic, right? Minus, no, that's linear. This was the cubic, so I probably should make it look more like a point of inflection. Kind of cubic 0. All right, so I lost my train of thought. Oh, greater than or equal to 0. So I can see this now. I'm greater than or equal from -infinity to -2. And -2 works, bracket. So does 0, union 0. That works, that number works. And 3 to infinity. Right? And hopefully we're starting to get a little better at that. Tangent of 3 pi over 2 is undefined. Why? Here's 3 pi over 2 down here. What's the height? -1. What's the width? 0. And the tangent is the sine function divided by the cosine, planting a seed here. Just keep talking about that the rest of the term. So -1 divided by 0 is undefined. 5 minus 4i squared. Square the first. Square the last. Middle term double. Double that product. 25 minus 16 is 9 minus 40i. Okay, again, I hope you're pausing the video. 75, so we're going over here, Renee. Let's go over to 76. Let's get this out of the way. Right as a product. I'm seeing the difference of 2 squares. 3x plus 1, 3x minus 1. What am I going to do? I'm going to divide by 3. So that's 5/3. Then I'm going to do the inverse of E, which is the ln of 5/3. And then I'm going to add 4. Let's use the rules of logs this time to get an approximation. ln of 5/3 is the same thing as the ln of 5 minus the ln of 3 plus 4. Well, that's 1.6 minus 1.1 plus 4, so that's 0.5 plus 4, 4.5 is an approximation for the answer to that question. All right, 8 plus or minus I came from what equation? It came from x squared minus 16x plus 65, I believe, equals 0. I believe it came from that. Let's find out. All right, so I'm going to subtract 8. I'm going to square it. X squared minus 16x plus 64 equals I squared. I squared is -1. So I'll bring it to the other side. And I didn't make a careless error. That's good. So I did one. I made a careless error 2 or 3 videos ago. So I didn't that time. Let's get rid of this. If I run into any trouble, I'm not going to be doing it again. So you're going to see me stand there and go, oh, my brain just stopped. 49. So that's 5 root 9 root 5. 3 root 4 root 6. minus 2 root 4 root 5. All right, so it looks like I got some root 5s. So that one is minus 4 root 5. This one is 15 root 5. All right, 3 times 5, 2 times 2, okay? So 15 root 5 minus 4 root 5 is 11 root 5. And I've got 2 times 3, 6 root 6. All right, so that should be that answer. Just doing them with you, trying to make space here, the final frontier. So instead of finding roots, I'm just solving an equation here. The intersections of these two graphs. Can you pause the video and write the following? X equals 7 plus or minus the square root of 4 times 5, 2 root 5. I believe that is correct. Let's find out by putting it into graphing form. A is 2, x minus 7 squared plus 10. I'm seeing that parabola equaling 50. Well, I hope you're going to subtract 10. I hope you're going to divide by 2. I hope you're going to take plus minus square root of 20. I hope you might see that that's plus or minus the square root of 4 times the square root of 5. And then I hope that you bring 7 over and write plus or minus 2 root 5. I hope that's what I wrote before. Oh, guess I did. All right. So how do you get from 10 to 50? You got to go up 40 units. And these are all the inverse operations that go with what I'm hoping you see eventually. Point of inflection for this cubic. Minus b. 3 times a. 2. Therefore, I know I have x minus 2 cubed. I have x minus 2 to the first power. And if I put a 2 in, I get 8 minus, it should be minus 24 without looking. Positive 2 minus 4 plus 5. I hope I'm getting minus 16 plus 1 up. I'm getting minus 15 correctly. Hope so. Now we got to do c minus 3ah squared. Of course, I erased something I shouldn't have. That's okay. So c minus 3ah squared is going to tell us if we have maximums or minimums, local max and local min. Positive 2 minus 3 times a, which is 1, times h, which is 2 squared. That's minus b over 3a. So we get 2 minus 12. So we're going down at 10 to 1. So the graphing form was x minus 2 cubed minus 10 times x minus 2 minus 15. And our point of inflection was 2 negative 15. This is for you calculus folks, that's the equation of the line tangent to the point of inflection. So my tangent looks like that. What happens? This eventually takes over, swings it back up, swings it down. And these are easy to find now. These are easy to find. So I know I'm moving backwards from 2. I'm moving from here, that direction from 2. Square root of, it was going down at 10 to 1. So it's going to be 10 divided by 3 times a, which in this case is 3. God, I hope I remember to do 3 times a in the others. It's real easy to get muscle memory from other problems that creep into this. So then this one is x equals 2 plus the square root of 10 thirds. And I don't know the y value that goes with that. Probably a calculator would be very useful at that point. Where's the y-intercept? I'm going down, so it's right here. That is 0, 5. And at that instant, I'm going down at 2 to 1. And we hope to look at that by the end of the term as to why. We've got some drawings of cubics, and we're going to look numerically and geometrically at a much deeper level, but not yet. Rome wasn't built in a day. I want to get you familiar with c minus 3ah squared, get you familiar with minus b over 3a, so on and so forth. All right, to help you get familiar, I will do one little exercise here. It'll only take a minute. So here's a cubic. 0, 2, and 10 are roots. So it looks something like that. And I'll ask you, where would you put the x value for the point of inflection? Remember, every time I ask a question, you're pausing. You want to, because I'm just going to keep going because of the length of the time of the videos. Well, I hope you put it here. Does it look like that might be 4? If that's 0, 2, and 10. Sure looks like it might be, right? And what's 0 plus 2 plus 10 divided by 3? I'll let you do that. Oh, big coincidence. Big coincidence. And what is it? It's a cubic. That's not a perfect cube. Right? You've heard about completing the square, yes? Well, this is just one step up, completing the cube. Right? And this might be x minus 2. This might be x minus 10, and that might be x. Right? And what do I have to do? I have to change it into a perfect cube where I have x minus 4 and x minus 4 and x minus 4. And when you do something like that, you get those first two terms when you cube it. If I had this problem, and I don't have it written in this form, but if I had it written in this form and I multiplied this out, I'd get the first two terms. That comes from completing the cube. E to the 1 over x, what's the y-intercept? Let's do it here. E to the minus 1 over x. Well, let's put 0 in. I hope you say there's no y-intercept. Can't divide by 0. Can't work with that number. Okay, future classes. Future classes. You got to be able to graph that, and look at the area trapped between the two graphs. So x squared minus 6x is x times x minus 6. The quickest way to get that is to factor it. And so at 6 and 0, we get a parabola. Y equals x cubed comes up. And I don't know if there's any bounded area there. I got a feeling that's going up faster than this is. So, interesting. Interesting. But where do they intersect? It might just be one location here. Might just be one location. Let's find out. How do we find out? We set them equal to each other. X cubed equals x squared minus 6x. So therefore, x cubed minus x squared plus 6x equals 0. I'll take out what's common, which is 0, times x squared minus x plus 6. I got a feeling that you don't have an intercept there. You do not have an intercept there. All right, and I'm not going to work with minus b over 2a. Take too long here. Okay, but doesn't look like they intersect except one place, and the other two roots are imaginary. And the graph seems to bear that out. What's the y-intercept for y equals 3? I don't know why I asked that question, but there's the graph of y equals 3. Sure looks like it's 0, 3. Not quite sure I wanted to ask that, but I did. F of a minus b. So f of x tells me to double something and add 3. What am I going to double? A minus b. So what does that equal? It equals 2a minus 2b plus 3. That's that. Okay, so I've done this to get that. Now I got to do what? F of that. So now I got to do f of this. And what does f of x ask me to do? It asks me to double the input and add 3. So my new input is 2a minus 2b plus 3. And then I got to add 3. So your final answer, 4a minus 4b plus 9. All right, so that takes care of this one. Minus ln of 5 minus ln of 3. I've got subtraction, so my activity is going to be in the denominator. That's the same thing as the ln of 5 to the negative 1. I can bring that negative 1 there. Plus the ln of 3 to the negative 1. I can move that minus sign. And so that gives me a 1/5. That gives me a 1/3. And that's the same thing as the ln of 1 over 15. I can multiply those. Okay, so can we actually see this come out? Well, let's do it. Let's get some practice here. The ln of 115, let's get an approximation so we can see the rules of logarithms. So that's 1 over 15 in E notation is e to the 0 over e to the 1.1 times e to the 1.6, right? 3 times 5. So I'm seeing 0 minus the ln of 3 minus the ln of 5, which is kind of what we're writing here, no? Nice, hoping that that's becoming something that you're beginning to see. What's the period of this function? Multiplying by 20. So I'm looking at 20 into 2 pi. I guess the period's pi over 10, which is about 0.314. So I'm getting a sine function, which normally ends at 6.28, 0.314. Boom, 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 boom. I'm getting something like that. Why? Because as you walk around the circle, you get a graph that looks like this. Well, what if I walk around the circle 20 times faster? Boom, you get a graph that looks like that. I increased the speed at which the angles are coming at us. Wonder what that means. All right, so it's a shortcut. Where's the shortcut come from? Well, we know we want 20x to equal 0, the start of the revolution. Then we want 20x to equal 2 pi, the end of the revolution. Go check. So when does 20x equal 0? Starts at 0, ends at what? When does 20x equal 2 pi? When I divide 2 pi by 20. Geez. The multiplier. 20 divided into 2 pi. Yeah. Does seem like we could have shortcut this by going straight to that. All right. Name that tune. Number 88. Name that tune. Let's get a little closer here. All right. I see a parabola. I see x minus 3 squared plus 9. I see my change is 16. When I drop in a 7, it's not 7 minus 3. That's not the change. It's 7 minus 3 squared. That's the numerical change. And if that change doesn't get us the change we want, sounds like a political ad, then we say, how do I get from 9 to 53? I think I got to go up 44. Looks good to me. Running out of ink. All right, I'm going to start with y equals 20. I'm going to go to 5. That's down to 15. It's a logarithm. Asymptote at 4. So x minus 4. 7 to 4 is 3 units of change. And 11 to 4 is 7 units of change, not 3 units of change. So let's drop 11 in. And I get 7/3 for a base. That's that log. Let's put 11 in. What do you put on top of 7/3 to get 7/3? 1. 20 minus 15, 5. Let's put 7 in. 7 minus 4 is 3. 3 divided by 3 is 1. What do you put on top of 7/3 to get 1? 0. 0 times 15 cancels that, and I get 20. You can get good at that if you keep practicing it. Why did I give that? I don't know. I hope you say x equals 0. Vertical line. Doesn't matter what the y's are. I think that's going to be a 0 something. Let's erase that. You're trying the next problem. Pause it, I hope. What do I see? I want pi to act like pi over 2. Because I'm going to do a sine function here. So I've got x minus pi gets me pi over 2. Yep. That's going to get me the number 1 in the sine function. What am I doing to the sine function here? I'm changing it by 80 to 90, so that's 85. I'm going up 5 and down 5, right? And now I got to get the period from pi to 5 pi. That's a change of 4 pi. I don't think I want 4 pi. I think I want 1, 2, 3 pi. Looks to me like the pi's canceled. And just following the mechanics, now I could multiply this out, and just like we do writing the equation of line in slope-intercept form, we could put that line in slope. This is just a line. right? All I'm doing is unwrapping the unit circle and making certain numbers, right, become, so unwrapping the unit circle is linear, right? And I'm making pi turn into pi over 2, and I'm making 4 pi turn into 3 pi. And all I'm doing is y2 minus y1 over x2 minus x1 in the manner in which we've been doing it since lesson 1. Okay, so this is all about angles. I think I forgot to write 85 here. Right? That is that function. Hopefully you got a little practice. And if you couldn't do it, well, I hope you followed. That's the first stage of learning, is following. We're getting there. This is going to be over an hour, I think. Okay, now I got to get this closer. Now, I'm not talking, and all you're doing is writing answers on an answer key. I've had students finish these, 107 questions in 40 minutes. So we're not going to ask you to do 107 questions in one sitting, but hopefully you're getting to the point where you can just look at that and say, oh, okay, 5, -4. And I think I made a mistake on one of these recent lesson sets, going up at 2 to 1. So 6 goes up by 2. So just connect those two dots. 5, -4, maybe here. 6, -2, maybe just a little bit there. And I'm going up, right? Yes, I'm going up. There's that graph. Just for the sake of time, I'm doing these quickly. So minus 3x squared is that. My y-intercept is 2 on the downside. So 0, 2 is here. So now I know that x is negative. 24 divided by -6, -4. If I put -4 in here, I'll cut it in half. -2 times -24 is 48, plus 2 is 50. All right, so you got to plug -4 in here. I'm taking shortcuts at this stage. And there's that graph, which means we have the roots, we have equations we can solve immediately. And therefore, there's no need for the quadratic formula in a lot of instances. -4, positive e to the x, so we have growth. I want to make that a 0, so I'll put a 1 in. And that's going to get me a jump of 10 from -4, which is going to get me 6. And I want that to equal 3, so that's 5 halves, 2.5, we'll call that 5 halves. And that jump of 10 is now going to become a jump of 30. Oh no, I want this thing to equal 1.1. I just butchered that comment. So when does 2x minus 2 equal 1.1? Well, that's 3.1 divided by 2, which is 15.5, I think, 5.5. Sorry. Yeah, I'm at that stage, aren't I? 1, 2, 1.1, 5, put a 0, another 5. All right, should be that. 1.55, yes, 1.5 plus 1.5 is 3. Yes, okay. Oh, that was awkward. So 1.55, and of course I erased the thing. So -4. You said what? 1 gets us 6. And I think if I remember, I said 1.55 gets me 3, 30 minus 4, 26. Hopefully that's right. I've got to change the ink cartridge here. Just take me a second. I'm getting a little better at remembering what I need to bring into the room so that it doesn't take too long. All right, there's the four glasses. There's the cartridge. Okay, Renee, I'll clean you up later. There we go, new cartridge. And now we're looking at a new problem. These are gone. Again, if somebody spots a mistake, just write it in the comments and I'll make sure I put it in the description paragraph as to watch out, mistake made. So -1 makes a 0. It's a negative, so I should have a linear function, not a linear ln function, decreasing. Where am I at? I want the ln of 1, and the ln of 1 is going to be 2x plus 2 equals 1, so that's -1/2. There's something wrong here. So this should have been -1. And negative 1/2, I believe, is going to be there. If I plug that number in, I get the ln of 1, which is 0. So this becomes 2. Because multiplication by 0 is very helpful. That's what the course is based on. I like the ln of 3. Ln of 4 works here easily. So let's put a 1 in. A 1, let's say a 1 is there. That gives me the ln of 4. The ln of 4 is 2. ln of 4 is 2 squared to the 0.7. 2 to the point, e to the 0.7. Yeah, I'm losing my train of thought, right? So that's 1.4. And so now I get minus 1.4 plus 2 is negative 0.6. Okay, so I hope I didn't make any mistakes there. Not going to check it because we're taking a long time on this video. Just getting practice. So what do I see? I see 2 pi, 9 units. Cosine function, I'm just going to do that. Max to max, because the maximum width on the sine, maximum width on the cosine function is at 0 radians. What makes a 0? 1700. That makes the cosine 1. 5 times plus 10 is 15. Right? And I'll put in the 10 is the midline. 15 is the biggest. So therefore, I have a 5 here. But let's find that one. That one happens 9 units later. 1709. I should come back to 15. So 17 what? Where am I at? Well, I don't want to do that. I'm losing track of my train of thought. So that is going down to 5. That's good enough. All right, you know the range. You can find the maxes. It's done quickly. Good enough practice. I want 1 revolution, right? Every 9 units. 3. So first thing we want to do is put that in factored form. Last thing I want to do is get hung up with a fraction when my brain's tired. So 3 over x minus 5, x plus 5. I can immediately see that I cannot make this equal to 0. There's no variable in the numerator, and a fraction is 0 only when the numerator is 0. Okay? Sometimes they're still undefined if we make, well, anyway, enough of that. So 5 and negative 5. It's going to 0. Checking that out, the bigger the numbers you put in here, the smaller the fraction gets. All right, 0 gets me what? 0 gets me negative 3/25. We'll just put a 0 there. Negative 3 over 25. I get sign changes. They're to the first power. Those roots, those not roots, but factored form, first power. So I'm going to get sign changes. If I put a big positive in, I can see it's that. So therefore, this one has to be negative, and then a sign change at negative 5. So no sign change here, no x-intercept. We said there are no x-intercepts. So it's got to look something like that. And then we get a sign change, so it's got to look like that. You want to verify it, throw negative 6 into the equation. I'm going to let you do that, and you should find a positive result. So when am I going to infinity? As x goes to infinity, I'm heading to 0. We can see that right from the get-go, I hope. And what about 5 from the right? As I come in from 5, 10, 9, 8, 7, 6, 5.5, 5.1, 5.01, I'm going to infinity. When am I less than 0? In between the asymptotes. These are positive. So therefore, that answer is x less than 5, greater than negative 5. All right, that takes care of that. Almost getting there. 7 more problems. Now, do I know what 1 over the square root of x looks like? No. But in my mind's eye, I would write y equals 1, and I would look at the square root. Right? So eventually this thing's going to 0 because this is fixed. That's a height of 1. This is getting bigger and bigger and bigger. So I know there's asymptotic behavior on the right. I know at that location I get a 1 because they're equal there. So I know at least this, and I know I'm eventually doing that. And I know it's undefined over here because the square root has to be positive or 0. And so 1 divided by that, well, I think that's going to get me some small numbers. Right? What happens when I put the square root of a half?
The square root of a half is root 2 over 2, which is 0.71. Well, that actually goes in more than one time. So this thing actually starts to come up, and I think we're looking at something like that, something similar. So this graph is something similar to 1 over x on that branch. 1 over x looks like that as well, except I think we're going to be more slowly approaching 0. That's my guess. But that's one to put in the calculator and just get a sense of, did I make some gains with it? Intellectual gains with knowing what one function looks like, knowing what another function looks like, and really this is a y value, and so is this. It's a second y value, right? And I'm really doing y1 minus y2 here. And what's happened to y2? It's considerably getting bigger than y1, right? That distance is divided into a smaller distance. It doesn't fit. Fits a small amount of times as this line gets bigger. That's staying the same. So this goes into that fewer times than it did before. All right, so just putting some thoughts in your head. I actually think that's, well, I want to go up on a tangent here. So that's V shape up, 5 9's the vertex, throw a 0 in, 29. And then I hope you can see you're going down at 4 to 1 on this side, going up at 4 to 1 on that side, if you take the time to do a little slope work. All right, so that takes care of that. Boy, I'm going to need a nap after this one. Grandpa needs a nap. Yeah. All right, 4x plus 10. 4x plus 10. Yep, there it is. There's 4x plus 10. 2x minus 6. There it is, 2x minus 6, not going up as fast. I'm dividing this y value into that y value. Well, I hope you can say you're getting around -3. That's a negative amount. This looks to be about 3 times the size. So somewhere in here, close to the origin, I should get -3. Continuing to try to plant a seed. So let's cut to the chase. 4 divided by 2 is 2. All right, so I know this has n behavior of y equals 2 on the right and left. 10 over -6 is close to -1.5. So we'll call that 0, -10/6, which is -5 over 3. Got a y-intercept. +3, asymptotic behavior. X-intercept at -2.5 minus 2.5 gets me a 0. I think I can see this now. And if you want to verify that, you got to work with numbers. I keep saying that. Throw a -10 in. See what you get for a value. Well, let's find out. -40 plus 10 minus 30. I might have made a careless error. -20 minus 6 minus 20 minus 6 is -26. Yeah, I'm a little less than +1. I'm below 2. I'm in the right terrain. Okay, so let's get rid of that one. All right, so I got a base 1/3 log with a positive multiplier. So therefore, I've got an asymptote at 5. I know it's going to be the inverse of decay, which looks like that. And I should get my graph out for that. I'll do that the next time. So this is changing by 1 and then by 3. If I go over 1, I should be at 6. If I go over 3, I should be at 8. Those should be my friendly numbers. Let's put an 8 in. 8 minus 5, 3. What do you put on top of 1/3 to get a 3? -1. -4 plus 20. 2016. Put a 6 in. I should get 2020 without looking. Let's find out. 6 minus 5 is 1. Log 1/3 of 1 is 0. 0 times 4 is 0. And there's your 2020. You can replay the video. I found out that you can move this thing, the cursor in it. Yeah, this new thing called a computer. Yep. Boy, am I dating myself. So I got a jump of 30 and then a jump of 10 if I pick the right numbers. So I got 30, I got 10 sitting on top of 4. So I now know that that is 14. I now know that is 34. Probably better off in the future just finding the two coordinates that matter. So x plus 1, 5. I got a -1 and a +4. So I got a -1 and a +4. And that should be my graph. I'll move the points a little bit in this direction. Let's see if it works. -1 plus 1 is 0. 1/2 to the 0 is 1. A jump of 30. Enough said. A lot of you are getting those right easily now. That's good. Hopefully you continue to be able to work with them. Cosine function. I'm going to do the same thing. Max to max. What makes the 0? 6. What makes a 2 pi? 6 plus 2 pi. That's going to get me 7 plus 5, 12. Which means that 6 plus pi should get me, let's see, the midline is 7. And multiplier is 1, so it's 2 pi. That's the period. That's what I noticed. That's why I wrote that quickly. What question? Oh, down 7 from 5, -2. All right, let's actually plug this in and see if it comes out to be -2. So 6 plus pi. Oh, the 6's cancel, and I get just pi. Pi is the left side of the circle. What's the cosine? The cosine is the width. There's your -1. There's your -5 plus 7. -5 plus 7 is not -2, so I correct that error right at the end of the video. And there, I'm changing by 5. Yeah, that's a better change of 5. That's a better up 5. That's a better down 5. Yeah, and so that's your graph. I forget what I asked. I think I asked the sine of 9. I think I asked, what is the sine of 9 approximately? All right, so you can scan the video. All right, so 6.28 is here. If I add another 3.14, I get a frame of reference of 9 point, so that's a 2, carry the 1, that's a 4, and I believe that's 9.42. So sine of 9 is 0.42 less than that location. 0.42, and this is 1.57. Right? 0.42 is about a fourth of the way up, a little less than a fourth of the way up. So there's halfway up, a fourth is there. So I think I'm right in here, 0.42. And then the question is, how much difference is that height than this? 0.42. Let's see, pi divided by 6. Let's get a frame of reference. 3.16 divided by 6 is 0.5-ish. So that would be a halfway up. Ooh, I'm having a little trouble with this one. My guess. So what is my guess going to be? My guess is going to be, I think I'm going to be wildly off. I'm going to go with 0.27. Of course, I'll stop the video now, then I'll go to Google and I'll look at the sine of 9 and I'll either be happy or sad. I don't know which, because I didn't really spend a lot of time with trying to nail that down. But I'm hoping I'm in the right quadrant, and with a little bit of help, a little bit of luck, maybe I'm in the right vicinity numerically. But I'll learn something from it, and that's what we're all about. All right. So I hope that you're keeping up with trying. I don't expect you to work for 2 hours a day, but just looking at the video, doing it in class, hopefully you're moving in the right direction. All right, stay safe, stay warm.